In our first two classes, we learned what DevOps is and mapped its lifecycle and tool chain. But that raises an uncomfortable question. How do you actually know whether your team is any good at it? For years, teams argued about this with gut feeling and opinion. Then a research program called DORA changed everything by distilling software delivery performance down to just 4 numbers and 4 metrics that reliably separate the elite teams from the struggling ones. Today, we will learn all 4, 2 that measure your speed, 2 that measure your stability, and why the very best teams refuse to trade one for the other. By the end, you'll be able to look at any team, including your own, and measure honestly how well it truly does DevOps. Here is what we will understand today. First, what DORA actually is. Second, deployment frequency. Third, lead time for changes. Fourth, change failure rate. Fifth, time to restore. And sixth, how these split into speed and stability and why both matter. Let us begin. Let us start with what DORA is and why you should trust it. DORA stands for a long-running research program that studied tens of thousands of engineering teams over many years, asking a single question: what actually distinguishes the teams that deliver software brilliantly from the ones that struggle? This is not one company's opinion. It is one of the largest bodies of evidence in our field. And the remarkable finding was that you can capture delivery performance in just 4 key metrics, 4 numbers, and no more, that together tell you how well a team ships software. That is the gift of DORA. It took a vague, endlessly debated question and 84 to well, are we a good team? 2000 turned it into 4 things you can actually measure. So the takeaway, DORA is years of rigorous research distilled into 4 metrics that measure real delivery performance, NA-A2112. Evidence, not opinion. Let us meet the first metric, and the first of our 2 speed measures, and A212, deployment frequency. Deployment frequency asks a simple question: how often do you ship changes to your users? Every time your team pushes new code into production where real users can see it, that counts. It measures the rhythm of your delivery. And the gap between teams here is startling. Elite teams deploy many times a day, each change small and safe. Struggling teams deploy once every few weeks or even months in large, nerve-wracking batches. This might feel backwards at first, and A2112. Surely shipping more often is riskier? But the opposite is true. Small, frequent changes are easy to check and easy to undo, while giant, rare releases are where disasters hide. So the takeaway, deployment frequency measures how often you ship to production, and the best teams deploy many times a day, and A2112, because shipping small and often is safer than shipping big and rarely. The second metric is our other speed measure, and it is a favorite of engineers, and A212, lead time for changes. Lead time for changes measures how long it takes for a single change to travel from the moment a developer commits the code to the moment it is running live in the hands of users. It is the length of your delivery pipeline, measured in time. Once again, the difference is dramatic. Elite teams get a change from commit to production in under a day, often in hours. Low-performing teams take weeks, sometimes months, for that same journey. Why does this matter so much? Because a short lead time means fast feedback. You learn quickly whether an idea works, you fix problems while they are still fresh, and you deliver value to users without long, painful delays. So the takeaway? Lead time for changes measures how long from writing code to it running in production. And the best teams get there in hours, not weeks, NA2112, because fast feedback is a superpower. Now we turn to stability, with the third metric, and A12 change failure rate, and A12, and it exists to keep the first 2 honest. Change failure rate measures the share of your deployments that cause a problem in production, and A202, a bug, an outage, anything that needs an urgent fix or a rollback. If you deploy 100 times and 5 of those cause trouble, your change failure rate is 5%. Elite teams keep this number very low. The vast majority of their changes land cleanly, doing exactly what was intended, with no emergency scramble afterwards. And here is why this metric is essential. Speed on its own is a trap and A212. If you ship 10 times a day, but half of those changes break something, you are not fast, you are just creating chaos quickly. Change failure rate is the check that stops speed from becoming recklessness. So the takeaway, change failure rate measures what fraction of your deployments cause a failure, and 212, a vital stability check, because speed is worth this if your changes keep breaking things. The fourth and final metric is our second stability measure, and it accepts a hard truth, and A212, time to restore. Time to restore measures this when something does break in production, and A2112. And eventually, something always does, and A2121. How long does it take you to recover and get back to a healthy state? It is not about avoiding failure, it is about how you respond to it. Elite teams restore service in under an hour, often in minutes. They can detect a problem, understand it, and roll back or fix it fast. Struggling teams can take days to climb out of an incident. This metric reflects a mature attitude. The best teams do not pretend failure will never happen. They build the tools, the alerts, and the practiced habits to recover from it quickly, so that a failure becomes a brief blip rather than a lasting crisis. So the takeaway, time to restore measures how quickly you recover when a change breaks something, and the best teams are back to healthy in minutes and 82 health, because fast recovery matters as much as avoiding failure. Now, let us step back and see how these four fit together, because their arrangement carries the deepest lesson of DORA. Two of the metrics measure speed, deployment frequency, how often you ship, and lead time for changes, how fast a change reaches production. Together they tell you how quickly your team moves. The other two measure stability, change failure rate, how often your changes break things, and time to restore, how fast you recover when they do. Together they tell you how safely your team moves. And here is the myth that DORA shattered. The old belief that you must choose between speed and stability, and 8200, go fast and be reckless, or go safe and be slow. The research proved that the elite teams are fast and stable at the same time. Good practices improve both together, they are not a trade-off. So the takeaway, two metrics measure speed and two measure stability, and A202 tool, and the best teams excel at both at once, because with the right practices, speed and stability rise together. Before we finish, let us be clear on why bothering to measure these four is worth your while. The first reason is that it replaces opinion with data. Teams waste endless energy arguing about who is fast and who is careful, all of it based on feeling. These four metrics end the argument by simply measuring the truth. The second reason is that they give the whole team a shared scorecard, and A21, four numbers that everyone, from engineer to manager, can see, track over time, and rally around, improving together. Alignment comes from a common measure. And there is an old engineering wisdom underneath all of this. You cannot improve what you do not measure. Without numbers, improvement is just hope. With them, it becomes a plan. So the takeaway, measuring DORA replaces opinion with data and gives your team a shared scorecard, and A212, because you cannot improve what you do not measure. Finally, a few words on using these metrics well, because it is easy to use them badly. First, measure honestly, and 8212. Get a real, truthful baseline of where you stand today, even if the numbers are ugly, because an honest starting point is the only useful one. Then improve one metric at a time. Find your weakest of the four and focus your energy there, rather than trying to fix everything at once. And here is the crucial warning, never gain the metrics. It is easy to make a number look good while making your software worse, and 8212. Deploying empty changes to boost frequency, for instance. The goal is always better software for your users, not prettier numbers on a dashboard. Treat DORA as a compass that shows you which way to improve, not as a whip to beat the team with. Used with that spirit, it is one of the most powerful tools in DevOps. Now the takeaway, baseline honestly, improve your weakest metric first. I never game the numbers, and 8-1, 2, use DORA as a compass toward better software, not as a target to hit for its own sake. Let us gather the whole class in one breath. DORA distills years of research into 4 metrics of delivery performance. Deployment frequency measures how often you ship. Elite teams many times a day. Lead time for changes measures commit to production. The best get there in hours. Change failure rate measures the share of deployments that break something. Time to restore measures how fast you recover when they do. 2 metrics for speed, 2 for stability, and A2112, and elite teams win at both together. Next class, version control with Git, the foundation of it all. One idea at a time. That is DORA and A24, 4 honest numbers that turn DevOps from a slogan into something you can actually see improving week after week. Measure your speed, measure your stability, be truthful about where you stand, and then get a little better at your weakest one. Do that, and you are no longer guessing whether you do DevOps well, and A2112 you know, and you know exactly how to get better. We will see you in the next class.